I find most exciting is actually working with the farmers and hearing their perspective. We're monitoring net greenhouse gas emissions. It's one site on a commercial dairy farm from the cropping side. So crops that are grown to feed the animals. They have a significant contribution to the carbon footprint of milk, so it's important that we get representative values of a typical commercial farm.
We run about 300 acres of land and milk 125 purebred Holstein animals. The project that we're conducting on our farm is the Living Lab Ontario project. And the research incorporates what the carbon dioxide and nitrous oxide emissions and sequestration that's happening with our cropping system on our farm.
So we take soil samples once a week after fertilizer applications, and then a month after the fertilizer application, it switches to biweekly soil sampling, and then within the third month, we're taking them once per month.
The reason we call it a supersite is because we have very sophisticated instrumentation that gives us data 24/7, 365 days in a year. And with that, we can characterize emissions from this one site really, really well. That's important because when you try to describe emissions through things like models and metrics, we need this kind of detailed data to get confidence in the models. We often talk about making the invisible visible with this equipment because we can't see the gas coming out, but as we measure it, we're able to know how much is coming out and when during the year. This alfalfa field has been harvested. This was second year alfalfa. The field over there was planted in soybeans in the spring, and it has already been harvested. The year before it was in corn, so we are just following the rotation that Hardcroft Acres does on these fields, alfalfa, corn silage, and then soybeans. Most of it is fed to the animals right here.
We spend a lot of time and energy making sure that our animals and our soil are both equally healthy.
So the practices that we're looking at here on this farm have to do with nitrogen management. So nitrogen is an essential nutrient for crops, so we still want to apply it in various forms like manure or inorganic synthetic fertilizer, but also it has an environmental impact through the losses of nitrogen gas, that particular in the form of nitrous oxide, which is a greenhouse gas. So what we're doing here is measuring nitrous oxide. We combine the measurements on this tower with measurements sampling gas at two heights, and then we get how much nitrous oxide is reduced by practices that we apply. So the practices that we're looking at for nitrous oxide specifically are the use of inhibitors, or sometimes people call those fertilizer stabilizer. So it's a special formulation that is aimed at slowing down the microbes that produce the nitrous oxide in the field. So here we have a large, last year, a large cornfield that was divided in two halves, where half received this enhanced efficiency fertilizer and half didn't. And we saw a reduction of 30% due to that enhanced efficiency fertilizer use.
For about 10 years, I've been doing that, balancing the nutrients in the soil, the nutrients in our organic amendments or manure. So it just made sense when I was part of one of the meetings and they were looking for a producer for us to volunteer. I always have wanted to kind of expand that to the soil because the animals and the soil are so interconnected.
We need to work at how does that translate to something that is relevant to farmers. So I think success for me will look like being able to have that message in a way that it's relevant, not just for this one particular farm, but for the whole dairy farmers of Ontario, and I would dare say maybe of Canada. that would be really cool.